quickly with a short history of the Vergnet company. What we understood with our long experience now of the grid key issue, especially isolated grid key issues. What are the key factors for quality and profitability? And finally, what we achieved, and with a small case study. So a short history, who is Vergnet? Vergnet is a French company, middle-sized. It's about 120 employees. We've got subsidiaries around the world, in French Caribbean, in Africa, and in the Pacific Ocean. We have test centers and test turbines also. We also have water and solar divisions, which I will only speak about wind here. We manufacture, we design, we operate, and we install our turbines. So we master the chain of value of the wind turbines. Our product range is not that wide, but very focused on medium-sized grids with the GMP, is 275 kilowatt turbine. What we call the swing system is a JMP with a package done by Caterpillar that we optimize together. And we've got the 1 megawatt turbine that we will only provide for the Caribbean and the French islands where you have cyclones. This is a short list of what is more dedicated to your problems. That means small grids, isolated. We go from 400 kilowatts to a couple of megawatts, starting in 1992 in the French island. These are only islands. That means small spinning reserve and isolated. And I could have added 2 other projects, one in Bering Island and one in Spust, Kamchatka, that have just been running right now. So, in our experience, what are the key grid issues? You know, because you operate, that isolated grids are mostly based on diesel. I will not talk about very small grids. I will talk only about grids about half a megawatt to 10 megawatt installed diesel power. So you use diesel because they are reliable, they are sturdy, they are flexible, and the technology is very well known. The infrastructure is limited, quite easy to operate and to install, and the investment is not so high. But of course, the operating cost is quite high now, and getting more and more higher, because the main cost is fuel. The price is increasing, it will probably continue to increase. It's erratic, so it's difficult to have a forecast of the cost of the kilowatt, and it's a supply risk. The isolated grids are of course more fragile because the spinning reserve is quite low. And the problem is that consumers today, they want the same service nearly everywhere. So they refer to interconnected grid quality when they want electricity on their flags. That means security, reliability, and power quality. The security is security of the goods and the person. And reliability is to avoid blackouts. And power quality, I mean the frequency stability, the voltage stability, and also the filters. But on isolated grids, you've got a pressure to reduce the kilowatt-hour cost, so you are tempted to even increase the spinning reserves to save the fuel, and the consequence that the grid is even more fragile. So, to resume, the quality, security, and reliability is expensive to get. So, what shall we do to have a better profitability? How to reduce the kilowatt-hour cost with a good payback time? The solution, and everybody talks about it today, is to have a hybrid system. to add a renewable energy production with the diesel power unit. With that, you combine the assets of the two solutions, and you mitigate the drawbacks of the renewable energy that is intermittent. So the goal is to have still reliable, sturdy, and flexible power source, and to reduce the global specific consumption of the diesel, and to save fuel, of course. So, talking about wind power, so renewable energy, so the fuel is free. You've got low operating costs. The operating costs are mainly maintenance. Wind is often more stable than solar. Maybe it's not the case here because you don't have many clouds, but we experienced in other islands that when you have a cloud coming, the power output of the solar panels, they drop very drastically and very quickly. It's independent because the power is here. The trouble is that you need an investment that is quite significant, and it's still an intermittent energy. And last but not least, you need multi-competence staff to operate and to maintain both wind turbine and diesel engine sets. So, higher the wind, the more expensive the fuel, and the more profitable it is. That is very easy to say. How do you do that? We have in-house a very good electrical design office, and we are able now to simulate everything on the grid. We can go to your power station, do some measurements, simulate the grid, and be able to give very precise operating instructions to the people, or even to automatize the complete chain. So on this side here is simulation. On this side here is actual data we measured on our test bench with a real wind turbine. We made simulations of completely power drop and see what happens on the grid. We have this here the wind power variation and with the voltage and frequency. And the key of that is to have a combined control of the wind farm and the diesel. It doesn't have to be completely automatic, but you must be able to tell the people operating the diesel plant what they have to do in different cases of wind and of load. So the key ratio for hybrid wind diesel is the average wind penetration. It depends on the complete design of the wind source and its adaptation to the power station. This is the key factor for profitability. But it needs some strong electrical grid engineering to have this ratio as high as possible with the quality I was talking about, the reliability, the stability, and availability. I will probably shock some of my colleagues, but we believe that to achieve a high ratio, it's not really necessary to have very sophisticated devices. We focus on average penetration. We don't think that having a very very high instantaneous penetration is very effective. Of course, you can have a better quality with flywheel, dump loads, and storage, but it will, of course, increase the installation cost. The average penetration will be higher, but you need higher maintenance. And we believe that it's better to have very tough design, very reliable equipment, easy to install, easy to maintain, than to really add other equipment and add some few figures about the average penetration. So we believe that instant penetration ratio is only for pride, not really for profit. So the basic design we have here is always diesel gensets. They may have or not a controller. If they don't have, we can add one. The wind farm always has its controller. And we have here a SCADA system that are talking to the two systems together and monitoring and giving instruction for operation. So today we mastered two possibilities. The one I talk about on the shared solution, that is a swing system. It's a containerized diesel. It's plug and play. The automation is already defined. Or we can adapt to the existing grid with a diesel park that is known or not. If it's not very well known, we can go on site and do some measurements. Afterwards, we simulate the grid behavior. So in the first case, you need to replace the group or add some other groups because the group we propose are low load. In the other case, you use existing groups, but you need simulation engineering. All right. So I will read very quickly. The swing system, we achieved the G2 power class quality. I will read the picture afterwards. What we achieved, we are mainly focused on islands. It can be in the Caribbean or not. This is the Vanuatu, it's near Australia. We have an average penetration of about 20%, but it is very basic design, no automation between the diesel pump and the wind farm. Japan, on the contrary, it's a higher penetration with 40% average. It's exactly what I said before. They added a lot of flywheels, full integration and so on, because they wanted to have exactly the same quality than on the main island in Japan. So, but we think it's useless, but it should do it anyway. We're trying this game. A very last example, Noisy Mover Internet is very interesting because we came on an existing grid with 16 megawatt diesel, old diesels, and we added 16 turbines of 275, and we achieved now at the first stage 30% penetration. That's quite good. They save a huge amount of fuel. It's an industry. They ship iron ore. This is actual data measurements. So you can see here and there, it's the time percentage of above 40% of penetration and above 20%. And here you've got the load, in green the power of the wind turbine, and in small blue here the output that the computer gives to the wind farm, the set. And here the instantaneous penetration. And here the instruction given to the power plant to work with 2 diesel or even 1. So 30% average penetration with all diesels. That means about 30% fuel savings. So the conclusion, the technology is ready, it's tough. You can have significant savings with high quality and reliability. You can have package or tailored solutions. And the payback can be very short if the wind resource is good. Thank you for your attention. And this is a picture of the Vergnet.
Спасибо большое. Это действительно одна из тех технологий, которые сейчас используются. Мы ее используем активно, в частности, на острове